So what we have is the 2011 6B and the following. We got T1 going up this way and T2 going down this way. Now you got to remember is that when you're talking about motion in a horizontal circle, it's T1 is the bigger one and T2 is the smaller one. It's always the top one that takes more of the slack. Okay, so the first thing we might say is that its ratio of 11 is to 9. This means 11 T2s will equal 9 T1s, and essentially T1 is the same thing as 11 over 9 T2. It's the first thing we can learn from this. Okay, the next thing, A and B are two fixed pegs. A is 4 meters below B, no bother. A mass m kilograms, so that is mg going down here, is connected to A and B by two light inextensible strings of equal length. If they're of equal length, it means it's an isosceles triangle, and this means that A to this center of the circle, we'll call it C. AC is 2, BC is also 2. Okay, and it has uniform angular velocity omega. Find the value of omega if the ratio of the tensions in the string is 11 is to 9. Well, there's two forms we're going to use. First of all, we're going to use forces up. Forces up must equal forces down. Okay, because it's not sinking in, it's staying at the same height. Okay, so what we're going to do here is we're going to, because it's an isosceles triangle, we can call this angle X, and this is also angle X, because they're two congruent triangles. Okay, so that's no big deal there, right? So what we can say is that going upwards would be T1 sine X. So if you take T1, which is this one here, and we know it's going up at angle X. Here we'll do that better than that. Mr. Kenny here better than that. All right, so we go this angle here. We go T1. And then looking at our diagram, we could have said that this is angle X. So this is T1 cos X, sorry, T1 sine X moving upwards, and T1 cos X moving across. Likewise, we can say the same thing for T2, which obviously goes down in this direction here. So T2 is going to be, once again, cos X. So this is T2 cos X. And this is T2 sine X. Now, the force up, the only force up is the T1 sine X. And then it equals forces down, which is your T2 sine X plus your mg. Okay, so that's the first formula we're dealing with here. Okay, nextly. Now, it'd be worth noting that I'm just gonna, I'll finish off my workings here first, and then we'll deal with that next. Next thing is you need your centripetal force. Centripetal force, which is MA, is going to equal M or omega squared over, just M or omega squared. Okay. And the thing to remember of centripetal acceleration is the force, it's the force that's going towards the center of the circle. Well, there's two forces going towards the center of the circle. There's T1 cos X and T2 cos X. So it's T1 cos X plus T2 cos X, and that equals our M or omega squared. Okay. So far, so good. Now, our first idea would be that we take these two equations and we change T1 into 11 over 9 T2. So I'm going to use equation A here, and this is going to be equation B. Now, using equation A, we're going to have 11 over 9 T2 sine X. Then we're going to take this out here, so it's going to be minus T2 sine X equals mg. Okay, so that's going to be 2 over 9 t2 sine x equals mg. We're going to try the same trick with this one here. We're going to change t1 cos x into 11 over 9 t2 cos x plus t2 cos x. So 11 over 9 plus 9 over 9 is 20 over 9. So that's going to be 20 over 9 t2 cos x. And that's going to equal m or omega squared. Okay, so now we have two equations here. Okay, now what part of me is thinking about doing here is I'm thinking about stacking the two of these on top of each other. So I'm looking for sine over cos. I'm hoping to turn that into tan x somehow. Eliminate one variable for two. And then I'll show you the trick I'll be hopefully coming up with after that. So we're going to have 9 over 2 t2 sine x divided by 20 over 9 t2 cos x, and that in turn will equal mg over m or omega squared. So I'm hoping that a lot of things will cancel here. 2 of them will cancel. The 9s will cancel. So I'm going to get 1 over 10 tan x. And that is going to equal, the m's are going to cancel. I'm going to have g over r omega squared. Now, there's still two variables. I have tan x and r. But I think I have a way of getting rid of the r's. So if we go back to the very start, look at this. What is the distance from here to here? My radius. What's the distance from here to here? 2. Therefore, what's tan x? Tan x is 2 over r. So I had that nicely planned. Didn't even have to use the L's in the end. So 1 over 10 times 2 over r equals g over r omega squared. The r's are going to cancel. And then what we're going to find out is that's going to be 1 over 5. So g over omega squared is 1 over 5. Bring up the omega. Omega squared equals 5g. Omega equals root 5g. Remember, always check your work when you're done. See if we're correct or not. 5g is 49. Just to let you know. So we are correct. Suppose we'll just do it officially. 5 times 9.8. 49 square root of 49, 7. Omega equals 7 rad per second. And we're done. Okay, that wasn't too bad. 6b.